Welcome to my YouTube channel, General Mind. Today our topic is about how much information your brain can store. How does the human brain store information? The human brain is an incredibly complex organ that is responsible for everything we think, say, and do. It's also capable of storing an absolutely mind-boggling amount of information. To answer this question, let's take a look at how the brain works. Some neurons are responsible for processing sensory information such as sight, sound, and touch. Other neurons are responsible for controlling movement. For example, the hippocampus is responsible for storing memories, while the amygdala is responsible for processing emotions. In fact, the brain stores information in a distributed manner. What this means is that there isn't one specific place in the brain where all of your memories are stored. Explicit memories are memories that we are consciously aware of. According to some experts, we can only access about 10% of the information stored in our brains. This means that the vast majority of our memories are inaccessible to us. Unfortunately, as we age, the amount of information we can access decreases even further. In fact, the brain can store up to 2.5 petabytes of information. Neuroplasticity refers to the brain's ability to change and adapt over time. As we learn new things, new connections are formed between neurons in our brain. These new connections allow us to store and retrieve information more efficiently. For example, if you learn a new language, your brain will form new connections between neurons that allow you to speak and understand that language. To put this into perspective, this is equivalent to the entire contents of the Library of Congress. This is because the brain is constantly making new connections between neurons. And these new connections allow us to learn and remember new things throughout our lives. But what we do know is that the brain is an incredible organ that is capable of storing a truly mind-boggling amount of data. Also, make sure to hit the like button and subscribe so you never miss an upload. Thanks again for watching, and I'll see you next time. Others believe that there is a limit to the amount of information that the brain can store, and that limit is somewhere between 2 and 3 petabytes. This is because the brain has a finite number of neurons, and each neuron can only store a limited amount of information. Parallel processing refers to the brain's ability to process multiple pieces of information at the same time. For example, while you are reading this sentence, your brain is simultaneously processing the words, letters, and punctuation marks. This allows you to understand the sentence as a whole, rather than focusing on each word individually. The average person has about 100 trillion synapses in their brain. Chunking refers to the process of grouping individual pieces of information together. The recency effect refers to the brain's tendency to remember items that are presented at the beginning or end of a list better than those that are in the middle. By understanding how the brain works, we can develop strategies to improve our memory and learning. For example, if you were asked to memorize a list of grocery items, you would likely remember the first few items on the list, as well as the last few items, but you might forget the items that are in the middle. For example, if you were trying to memorize a list of numbers, you might group them together in sets of 3 or 4. This makes it easier to remember the information because it reduces the amount of items that need to be memorized. Each synapse can store up to 1,000 bits of information. This means that the total number of bits of information that can be stored in the human brain is nearly 10 to the 16th power. This is one of the reasons why older people often have difficulty remembering things. For example, you may not remember every single thing you ate yesterday, but you may remember having breakfast, lunch, and dinner. These are explicit memories because you are consciously aware of them. Of the two types of memory, only explicit memories can be transferred from one brain to another. This is why it's possible for someone to have their memories read out loud. During a brain scan, the individual will consciously recall specific memories, and the brain will show activity in the areas responsible for processing that information. Implicit memories, on the other hand, cannot be transferred from one brain to another. This is why it's impossible to have someone else's memories read out loud. Instead, memories are stored in a network of neurons throughout the brain. This allows us to access our memories in a more efficient manner. There is no scientific evidence to suggest that any information is stored in our brains after we die. We are constantly making new discoveries about the brain and its capabilities. One day, we may even be able to unlock the full potential of this amazing organ. Once the brain stops functioning, all of the information stored in it is lost. If we had to search through every part of our brain to find a specific memory, it would take far too long, and we wouldn't be able to retrieve that information quickly enough to be of any use. Each part of the brain has a specific function. Now, how does this relate to storage? Well, when we want to store information, the brain creates new connections between neurons. These new connections allow the brain to access that information quickly and easily. Example, if you want to remember someone's name, the brain will create new connections between the neurons that represent that person's face and the neurons that represent their name. This allows you to recognize that person in the future and recall their name. And still other neurons are responsible for thinking and reasoning. The type of information a neuron can process is determined by the type of receptors it has on its surface. However, it's important to understand that not all of this information is equally accessible. In fact, the majority of the information stored in the brain is inaccessible to us. This is because much of the information stored in the brain is implicit. Implicit memories are memories that we are not consciously aware of. For example, you may not be able to recall the details of every conversation you've ever had, but you may still be able to recognize people you've met before. This is because your brain has stored implicit memories of those people's faces and voices. For example, a neuron that has receptors for light will be able to process visual information, whereas a neuron that has receptors for pressure will be able to process tactile information. The brain is made up of billions of neurons. These neurons are responsible for processing and transmitting information throughout the body. Neurons communicate with each other through electrical and chemical signals. When a neuron receives a signal, it fires what is known as an action potential. This action potential is a brief burst of electrical activity that travels down the neuron. When the action potential reaches the end of the neuron, it triggers the release of chemicals known as neurotransmitters. These neurotransmitters then bind to receptors on the next neuron, which causes that neuron to fire its own action potential. And so the process of communication continues. In fact, neuroscientists estimate that the brain can store anywhere between 2 and 3 petabytes of information. To put that into perspective, a single byte is equal to 1 character of data, such as a letter or number. A kilobyte is equal to 1,000 bytes. A megabyte is equal to 1 million bytes. A gigabyte is equal to 1 billion bytes. A terabyte is equal to 1 trillion bytes. And a petabyte is equal to 1 quadrillion bytes. So if we were to take all of the information stored in your brain and convert it into bytes, we would have something like this. That's an awful lot of data. So how does the brain manage to store so much information? Now, it's important to understand that not all neurons are created equal. All of this information is processed and stored in different parts of the brain. It's important to understand that the brain doesn't store information in the same way that a computer does. So how much information can the brain actually store? As we mentioned earlier, neuroscientists estimate that the brain can store between 2 and 3 petabytes of information. In addition to implicit memories, we also have explicit memories. So, how much of the information stored in your brain can you actually access? Now, what happens to the information stored in our brains when we die? There is still a lot that we don't know about how the brain works. But one thing is clear: it is an incredibly complex and efficient organ. As we continue to learn more about the brain, we are beginning to understand just how much information it is capable of storing. One way that the brain is able to store so much information is by using something called neuroplasticity. Another way that the brain is able to store so much information is by using something called parallel processing. The brain is also able to store large amounts of information by using something called chunking. Finally, the brain is able to store large amounts of information by using something called the recency effect. These are just a few of the ways that the brain is able to store large amounts of information. Some scientists believe that the brain can store an unlimited amount of information. Ultimately, we don't know for sure how much information the brain can store. Thanks for watching. If you liked this video, please leave a comment below. Always appreciate hearing from you guys.